An inductor is a coil of wire wrapped around a magnetic material. Current flowing through the inductor creates a magnetic field, and magnetic fields do not like to change. As a result, an inductor is a device which tries to prevent the current flowing through it from changing. If the amount of current flowing through the inductor is constant, the inductor will be happy and it will not generate any forces on the charged particles flowing through it. In this case, the inductor behaves just like a normal wire. On the other hand, if we try to interrupt the current flowing through the inductor will generate a force, trying to keep the current flowing through it. If an inductor is connected to itself and there is no resistance in the circuit, the current will theoretically continue circulating forever. However, unless we are using superconductors, all wires have some resistance to them, and the current will eventually decay to zero. The larger the resistance, the faster the current will decay. But the larger the inductance of the inductor, the slower the current will decay. Once the current is at zero, the inductor will want to keep the current at zero, due to the fact that an inductor tries to prevent the current flowing through it from changing. Therefore, when we connect this inductor to a circuit, the inductor will initially create a force trying to prevent the current through it from increasing. But the current will slowly increase. The larger the inductance of the inductor, the slower the increase in current will be. After the current has stopped increasing and has reached a steady value, the inductor will then again be happy and not generate any forces. But when we try to turn off the current flowing through the inductor will then generate a force to try to keep the current flowing through it at this new constant value. If the inductor is then connected to a resistor, the voltage across the resistor will be the current multiplied by the resistor's resistance. The inductor prevents the current flowing through it from changing instantaneously. Therefore, the current flowing through the inductor immediately after we flip the switch will be exactly equal to what the current was before we flipped the switch, regardless of what the value of the resistor is. If the value of the resistor is extremely large, then the current multiplied by the resistance will also be extremely large. As a result, inductors can generate extremely high voltages, at least for a brief period of time. Since the current through an inductor cannot change instantaneously, when we try to disconnect an inductor from a circuit, we always need to provide a path for the inductor's current to flow. If we do not provide a path, the inductor's current will find its own path, such as through the air, through the open switch, or through other components that are not supposed to be conducting electricity. This can create very large voltages and cause considerable damage to the circuit. The ability of an inductor to create large voltages makes them very useful in the design of power supplies. But this ability also means that care must be taken to ensure that we never try to switch off an inductor without providing a path for its current to flow in. Much more detailed information about electric circuits is available in the other videos on this channel, and please subscribe for notifications when new videos are ready.